Day 708 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3741, minimum distance between three equal elements 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums, a tuple ijk of three distinct indices is good if nums of I is equal to nums of j's, which is also equal to nums of k. The distance of a good tuple is the absolute value of I minus j plus the absolute value of j minus k plus the absolute value of k minus I, where abs of x denotes the absolute value of x. Return an integer denoting the minimum possible distance of a good tuple. If no good tuples exist, return -1. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into the example, if you've been following along with this channel, then you know this problem looks quite similar to the problem we did yesterday. I just want to point out that the only difference is these constraints down here, right? These constraints are what makes this problem go from an easy problem to a medium problem. So right now we're on the medium problem. This is the second version. So let's get into the example. In example 1, we have our input nums equals an array of integers 1, 2, 1, 1, and 3. The output is 6. So as you can see already, we need to find three equal elements. You can already see we have 3 ones, 1 1 right here, and 2 ones right here. Boom. The explanation says the minimum distance is achieved by the good tuples 0, 2, and 3. So this 0, 2, and 3 represents each index of the 3 ones. We have a 1 at index 0, we have a 1 at index 2, and we have a 1 at index 3. Now we want to find the distance, right? So 0, 2, and 3 is a good tuple because nums of 0 is equal to nums of 2, which is equal to nums of 3, and they all equal 1. Its distance is the absolute value of 0 minus 2, right? So 0 minus 2, that comes from these two right here. So let's do that over here. We have 0 minus 2, that's going to equal -2, and that's going to equal 2 for the absolute value, right? Because the absolute value just wants to know how many units away from 0 is this, right? So this -2 is 2 units away from 0, so the absolute value is 2. Boom. Then we want to get the absolute value of 2 minus 3. That comes from this 2 and this 3, right? So 2 minus 3 is going to equal -1, which is going to equal 1 absolute value, because once again, -1 is 1 unit away from 0. So the absolute value of -1 is just 1. Boom. Then finally, last but certainly not least, we're going to do index 3 minus index 0, right? The absolute value of 3 minus 0. So let's get that real quick. We have 3. Sorry, y'all. 3 minus 0, that's going to equal 3. And then that is going to have an absolute value of 3 as well, because 3 is still 3 units away from 0. So the absolute value of 3 is 3. Boom. Then we want to add up all the absolute values. Boom. So let me put this right here. And let's add up all of the absolute values. So 2 plus 1 plus 3 equals 6. Boom, we got 6, and that is how we got our output of 6. So just in case that didn't make sense though, y'all, let's take a look at example 2. Boom, y'all. So in example 2, we have our input nums equals an array of integers 1, 1, 2, 3, 2, 1, 2. This time the output is 8. And as you can see, in this example, we have 3 equal elements, right? So we have 2 ones right here and a 1 right here. But then we have a 2 right here, a 2 right here, and a 2 right here. We're going to go with the 2s because we want to return the minimum possible distance. If we went with the 1s, the distance would be larger than 8. So we're going to go with the 2s because 2 has a smaller distance, possible distance. So Let's go through it. It says that minimum distance is achieved by the good tuple 2, 4, and 6. So as you can see, we have a 2 at index 2, we have a 2 at index 4, and we have a 2 at index 6. It says 2, 4, and 6 is a good tuple because nums of 2 is equal to nums of 4, and nums of 4 is equal to nums of 6, which they all equal 2. It says its distance is the absolute value of 2 minus 4. So let's do it again. 2 minus 4, that's going to equal negative 2. That's going to equal 2. Has the absolute value of 2. Then we want the absolute value of 4 minus 6, right? Those right there, right? So we do 4 minus 6 is going to equal negative 2 again, and that's going to have absolute value of 2. Boom. Then we want to get the value of 6 minus 2. Boom. So we'll come underneath this. We'll say 6 minus 2. That's going to equal 4. And that's going to have an absolute value of 4. Boom. Then we come right here. We want to add up all the absolute values. So 2 plus 2 plus 4 equals 8. And that's how we got our output of 8. Boom. Now, let's take a look at example 3 in case they try to throw a trick question our way and we can't create any tuples. So, in example 3, we have our input nums equals an array of integer 1. The output is negative 1. The explanation says there are no good tuples, therefore the answer is negative 1. So, in this case, we only have one element, right? So, if we only have one element, we cannot create a tuple. And it says right here, if no good tuples exist, return negative 1. So, since no good tuples exist in this array, we just return negative 1. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we want to do is we want to create a dictionary to map each number to a list of its indices. So we're going to declare a variable called freak, say colon, it's going to be a dictionary, key is going to be an colon, and the value is going to be an array of integers to store the indexes. And we can initialize it with a blank array like this. Boom. Then we're going to build the index list for each value. So we're going to say for I in 0 ... less than nums.count. We're going to open up the brackets and we're going to say freak square bracket nums square bracket I, come outside of that, comma, we're going to say default colon is going to be a blank array. So square brackets, close, open the square bracket, close the square bracket. Then we're going to come outside all of those square brackets and we're going to say dot append, open up the parentheses, passing I. So each time we see this element right here, we're going to append that index to this default array. Boom. Now we're going to create an optional result to track the minimum distance found. So we'll come underneath this. Hold on, y'all. Let's clean this up. I don't know why that's pushed over like that. Boom. So, boom, we're going to declare a variable called result. And we'll set that equal to, we'll say colon. And it's going to be an integer and put a question mark. Boom. Now we're going to iterate over each list of indices and only consider values that appear at least 3 times. So we're going to say for indices and freak.values where indices.count is greater than or equal to 3. We're going to open up the brackets and we're going to iterate through the indices, focusing on the middle index. This ensures we always look at the tuples I minus 1, I, and I plus 1. So we're going to say for I and 1 ... less than indices dot count minus 1. We're going to open up the brackets and we're going to compute the distance between the first and third elements in the triplet, then multiply by 2. So we're going to say let dist equal, open up the parentheses, indices square bracket I plus 1, come outside of that, we're going to say minus indices I minus 1, come outside all of those, and we're going to multiply by 2. Boom. Then we're going to update the result with the minimum distance found so far. If the result is nil, then we're going to use the large default value for comparison. So we'll come underneath this and we're going to say result equals min, open up the parentheses, result, question mark, 10 underscore 000 underscore 000 underscore 000 comma dist. Boom. And finally, if no valid triplet was found, we're going to return -1. Otherwise, we'll return the smallest distance found by coming underneath this, and we'll say return result question mark -1, y'all. Boom. That should be all she wrote. Let's give it a run. Okay, let's see. Oh, gotta put a var freak. Now let's run it. See if that did the trick. Okay, that did not. Let's change that A to a Q and let's run it again. Let's see, it's accepted. So now let's go ahead and submit it. Make sure it's still accepted. And look at that, y'all. 169 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, make sure you get one more look at the code. And yeah, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.